So, sir, this is a brief Dr. Shriyari Mehetre currently works at the nuclear university. He does research in plant fertilization and voluntary fermentation. You have some. Okay.
You got my mail. Once I send you mail, you got the mail.
He has sent his bio.
Okay, okay. Just a minute. My mail is open here only. No problem. Just stop the mic. ये आपका छोटा आपके लिए आपका छोटा
प्रेजेंटेशन
उनको फुल स्क्रीन दिखेगा जैसे हमें एक में फुल स्क्रीन में दिखेगा we'll be able to see this man he will be in full screen when 18 start how will he come down sir oh my any what is start 10:59 कितना स्टार्ट करेगा सर 11 से ही YouTube तरीका स्टार्ट होता है will be visible.
Okay. Can I start?
You can start. It is live on.
Good morning, dear friends. As a part of our Swachhata Pakwada celebrations, today we have a lecture by Dr. Sayaji Mehetre, who is working as a scientific officer F at Nuclear Agriculture and Biotechnology Division, BARC, Mumbai since 1999. He did his MSc Agriculture from Mahatma Phule Agriculture University, Rajouri in 1996. He completed his PhD in microbiology from Mumbai University in 2008. He was a visiting scientist at Northern Illinois University, United States of America during the years 2011 and 2012. He has published about 50 research papers in national and international journals and writing popular articles in national newspapers. Also, he is an editorial board member and reviewer of many scientific journals. He has 4 patents for his credit and developed 10 technologies which are widely used by industries and farmers across the country. He is a fellow of Maharashtra Academy of Sciences. Today, he is going to deliver a talk on BARC technology for processing of biodegradable waste. We welcome you, Dr. Sayaji Mehetre, and I hand over the mic to you. Thank you.
Thank you, sir. Good morning to all. So today I'll be talking about different technologies developed by Bhabha Atomic Research Center that are used for processing different types of biodegradable waste. So basically, you might be wondering like how BRC is involved in this type of activities also. But as a part, apart from the nuclear research or nuclear energy related work, we are also engaged in development of technologies that have societal applications. See, basically, scientists, they do the work into the lab, and while doing the work, they get some of the findings or some of the research that is so useful for the society. That is called as a spin-off technologies. That is a spin-off technologies that can be used for application to the society. See, basically, what is research is what? Research is like finding something, but when that findings is used for somebody, then it becomes a technology. See, there are bacteria, they make a curd. So that is a research. Somebody has invented the bacteria, they are making use of a curd. So when that curd is used for our consumption or making some industry and all these things, that is called as technology. So similar way, we are working into the lab for development of some bacteria so that are used for degradation of waste. You might be knowing like waste is what? Waste is like unused thing. Anything is not used, we call it a waste. So I'll have a small slides also. I'll just slides can be seen. Okay, so simultaneously I'll just go through some slides. Okay, so that is okay. So that will be useful for you to understand things better. Actually, basically, there are some bacteria. They are used. They degrade the waste actually. Okay. So based on this bacteria, we have developed a technology, or we have developed a process that is being used by societies. Okay. So by using this, we have developed a technology that is called as a Nisarguna technology. So we will be discussing more about this. But now I'll come to see, basically waste, we have to process the waste. Now being a Swachhata Pakhwada we are celebrating, so we are concentrating on the waste. So what type of waste are there? Usually it is available in your school books, it is available actually. So that is a waste is categorized as a non-degradable waste, biodegradable waste. Okay, non-degradable waste is what? Plastics, metals, glass, they all are non-degradable, means they cannot degrade by its own. Okay, so they are very, very tough for degradation. So what is the what is the method of processing these non-degradable waste? Is you can recycle, reuse. So that is the strategy used for treating non-degradable waste. Today we will be talking about biodegradable waste, means degradable. Biodegradable means degradable by using bacteria. Bio is life. Okay, so your waste can be degraded by using life form, that is a bacteria, fungi, viruses. So they are used for this type of process. So what are the biodegradable waste? Kitchen waste, garden waste, even agriculture waste, even paper is also biodegradable, isn't it? So this can be processed actually. So now whatever picture you are seeing on the slides, that contains like all types of waste, variety, like mixed waste. But from that we will be talking about biodegradable waste, that is a kitchen waste or garden waste. Okay, next. See, just this is statistics, but you don't have to worry for much. But it is roughly, it is said that in our family, suppose we have a family of 4 members, like 2 kids and family 4-5 people are there. Usually in our home, mostly like 0.5 to 1 kg waste is generated. Okay, suppose 1 kg waste is generated like every day. So in that 1 kg, 50% is called as biodegradable. Like you have some plastic is there, or some you buy some clothes, this one paper is there. But whatever food waste, like remaining food is there, like you bring some vegetables, and whatever chilka or that is part is there, that is your waste. So every household around 500 gram, like 0.5 kg waste is generated per day. Okay, that much is like roughly it is available, and it is a, if you calculate throughout the India, it is very huge, like 55 million tons of waste is generated every year. And see, this is not going to stop actually. So your waste will be increasing also, like it is increases in the quantum of 5%. Every year it is increasing to the quantum of 5%. And you have to remember that 50% is your biodegradable waste. So what are the, then see, this is like a very huge amount of waste is there. Now our aim is to reduce that waste. So what are the options available? What are the different methods are available? So commonly used methods, we will highlight that actually. First is called as a landfill. Landfill means like whatever waste we are creating from our home, we are giving to one person, that he comes to our home and he usually takes the waste, and from there it goes, and some areas are identified near to the cities, they are called as landfill areas, means they just dump the waste there actually. So whatever picture you are seeing there, like JCB and all this one, they are just dumping the waste. But now, like last 4-5 years, that dumping has been banned actually. So that is not allowed now, because that is creating a problem. Because what happens when you are dumping the waste, like amount of gases are released from there, mostly methane is released, carbon dioxide, carbon monoxide. And when you are dumped the waste, people, what happened, that methane that catches fire actually during high summer and all this, what happened, that methane, they catches the fire. So that whatever extra gases, they pollute your environment. So landfill is now banned actually, but still some people are there, they are playing the mischiefs and all this thing, but they are putting the waste onto the road. See what happens, you might be knowing this greenhouse effect. Greenhouse effect is a concept where it has been found that nowadays we are telling like a lot of heat is there. Now untimely rains has come. Now even cold in Mumbai, we were observing cold. Like during recent times, you might have observed like very low temperature has gone very low in Mumbai. So this is called as a climate change. Why it is happening? Because a lot of pollutions are there onto the whatever our activities are there, and that is creating the extra burden to the atmosphere, and that is called as a greenhouse effect. Greenhouse effect means what? There is an increase in the temperature of earth due to your pollution, like pollution due to air pollution and other pollution. So you might be knowing this, there is a layer around the earth that is called as ozone layer. Ozone layer protects the earth from the harmful effects of sun rays. So usually what happens due to these gases, they are damaging that ozone layer. So there has been, you might have read in newspaper or something like that, there is a hole into the ozone layer, and that has resulted into sunlight directly coming onto the earth, and that is creating the that is increasing the temperature. So this is called as a greenhouse effect. And what point I want to say that when you put the waste onto the landfill or onto the road, extra methane is generated. So that methane is more dangerous. See, if you compare methane and CO2, if one molecule of CO2 is damaging one molecule of ozone, there are 20 this methane, one molecule of methane damages 20 molecules of ozone. That means it is 20 times more dangerous than CO2. So you can imagine like how dangerous methane is. So when you put onto the landfill waste, then that is not good for our purpose actually. So that is the reason we need to process the waste. So there is a second technology available that is called as pyrolysis or incineration. There is second photo is shown there. That is pyrolysis means high temperature burning. So at a 900 degrees Celsius, 1000 degrees Celsius temperature, your waste is almost, it is burned, like it is charred. So you might be seeing like your waste is disappeared, but amount of gases generated during this process and then amount of energy required to get that 1000 degrees Celsius temperature is very huge. I mean, that is again not an environment friendly process. So what about next is pelletization. Third is a pelletization. Pelletization means what? What they bring the waste and they compress it actually. They compress in such a way that very high pressure, they compress and they remove the water part. Water part is removed and that pellets are made, and the pellets are used by different applications in the industries or this boiler purpose and all this. Though it looks good method or promising method, but again what is you are doing? You are not doing anything. You are just compressing the waste, you are removing the water and making the pellets. So very this one, what is that amount of energy required is also very high. So that is called as pelletization. So now next process, fourth process is the composting. Composting means there are bacteria under aerobic conditions. These bacteria convert your waste into good quality manure or compost. So we have a lecture by my colleague, one of my colleague, Dr. Paulami, that is on Monday. So she will be covering on this aspect. So I will not go more details on this aspect. Now another is a vermiculture. You might be knowing worms, earthworms. Earthworms, they are usually in our books, usually we read the sentence that earthworms are friends of farmer, because what they do, they make the that soil, they like plowing, like natural plowers. They are like a natural plow mechanism they do. And these earthworms actually they eat the soils and all these things, okay, dead organic matter and all these things. So there are some earthworm species, they are used to treat this waste, but directly, see problem again, see any technology is there are some limitations are there. Suppose earthworms are there, liquid waste is there, liquid food is there, you cannot put liquid to them. So whatever dry food or something like this is there, earthworms, they usually eat it. But they are like directly, they cannot eat all types of food also. So there are limitations. But vermiculture is also good technology, but it has a limitation. Limitation means it cannot be used very widely. Again, that is that earthworms, that is a temperature dependent. Even rainfall time, it is again some limitations are there or something like that. Okay, so this is a fifth technology that is called as vermiculture. Now methanogenesis. So I told you that there is a technology called as composting, where aerobic bacteria, they are degrading your waste or your organic material. Here in methanogenesis, anaerobic bacteria they use. Anaerobic bacteria means the bacteria, they survive without air. You might be means you see like even like seconds time we cannot live without oxygen, isn't it? But there are bacteria, they live without oxygen, and these bacteria, they are called archaebacteria. They are the ancestors, like they are the first organism they came on the earth. That is called as archaebacteria. So when they came onto the existence when there was no oxygen was there. So since that time they are living onto the earth, and these bacteria, they use the food material or whatever waste is there, they use as a carbon source or they use as energy, and they convert it to methane. So this is called as a methanogenesis. Methanogenesis means process of forming methane, that is called as methanogenesis. So whatever I will be talking about based on this technology. Now we will not concentrating on all these technologies. Now we'll be talking about methanogenesis. So you might be knowing like gobar gas in rural areas, most of the places this type of gas, gobar gas used to be there. That is called as the methanogenesis. Okay, so this technology is very old, but we have modified this technology or modified the process for processing. Earlier gobar gas plants were for processing only cow dung. Cow dung was used, but now with this methanogenesis technology or whatever Nisarguna technology I'll be talking about, so that takes all types of biodegradable waste. Okay, so now we'll go to the see, now I was telling you like see, any technology is there, it has some limitations are there, but purpose of the technology should be that your integration of all the cycles. Basically life is what these, see, all the organic things are there means they are made up of all these elements actually. So your technology should be in such a way that this cycle should not be broken. All the elements, see, basically what happens, plants, they are making the food, so they are taking sunlight and nutrients from the soil, they making the food, and we are using that food. When whatever waste is there, it again goes to the soil. Plant also, when it dies, it will go to the soil. So there is a cycle going on onto the earth. So that cycle should not be broken. So your process should be environment friendly or eco-friendly process has to be there. That is called as eco. So elemental cycle has to be maintained. So that is called as recycling. Okay. So this is the aim of the process. So this is the technology we have developed, or we have developed, that is called as Nisarguna. Nisarguna is a word made up of Nisarguna. Runa means loan. That is Sanskrit word. Nisarga is nature. So whatever the concept behind this I am telling, Nisarguna means, see, whatever waste is there, we are taking so many things from the nature in the form of loan. So if we take the loan from the bank, we have to pay back to the bank, isn't it? But in nature, we are not giving anything back to nature. Then how it will maintain? So our aim is that you process the waste through this plant. So whatever manure will come out, that manure will go back into the field. So you are paying back the nature's loan. So this is how the concept has evolved. So Nisarguna is nature's loan, and you are going back, you are processing the waste into this biogas plant, and whatever gas is there, you are using it, and manure is applied into the field. Okay, isn't it? So you are paying back the nature. That's why name is given Nisarguna. Nisarguna is nature's loan. So what it does actually, it processes hotel waste, municipal waste, agriculture waste, vegetable market waste, abattoir waste also. So all types of biodegradable waste can be processed. So how it works? So I will give you some. So don't. This looks actually complicated, but simple. I will tell you that this is a two digestion process. It is a aerobic digestion followed by anaerobic digestion. So earlier I told you gobar gas plant where single digestion, that is a anaerobic bacteria only we are doing. But now we have developed a double digestion, means there are two digesters. Two digesters means what? There is a aerobic digestion followed by anaerobic digestion. Why two digestion is required? Because amount of or type of the waste, like this type of waste I am talking about, hotel waste, municipal waste, agriculture waste, they are very, very complex. They are made up of a very, very complex thing. Complex means like they are a long, that is, see, basically waste is made up of what? Whatever way food is there. Na? So food, whatever unused food is there. So that waste is made up of carbohydrate, proteins and fats. Okay. When this carbohydrate, proteins and fats, you want to degrade it and you want to convert it to methane. So there are so many intermediate steps are involved. And one of the important step is that your waste is converted into organic acids. And these organic acids, they are used by methane bacteria and they convert it into methane. So this acid production takes place in this stage. So what happens is that your waste is passed through mixer, crusher, then it goes to the pre-digester. There we are adding some hot water so that solubilization, faster solubilization of waste takes place, and then you get a methane generation. So this is the process. Other things you don't worry about, only you have to remember that there is a double digestion system, aerobic followed by anaerobic. Earlier systems were only single digester. So this is how the technology has been developed for processing different types of biodegradable waste. So what are the advantages of this process? It is a faster degradation of waste, combination of aerobic and anaerobic, I told you, increase in quality of quantity of waste, quality and quantity of the methane. See, whatever, that process generates biogas. Okay. And this biogas contains methane and CO2. So more the methane, more the that value. See, whatever that is called as a calorific value. So more the methane, more will be the calorific value. So this process generate more methane. So this is, and recycle of the water. See, whatever water is remaining into the system after the process, we are removing the water, and again that water is used for different applications. And whatever solids are remaining, they are used as a manure. So this is the process actually. So these plants look like this actually. See, the digesters are below ground. So pre-digester, main digester. These are manure pits, then solar dryer, solar heater, then your mixer and all these things. So this is how the plant looks. It is a below ground. Okay, we have a plant just near to the training school hostel in Anushakti Nagar. Some students might be there from Anushakti Nagar colony. Na? So there is a plant just behind to the training school hostel, that plant. So this is the aerobic digester, then anaerobic digester, then manure pits. We don't have to go. So how this natural balance, I told you, na, any system that should have a natural balance. So what happens na, plants, they produce the food. They fixes the CO2. They take the CO2 from the atmosphere, then sunlight and nutrients from the water, and they make a food. That food is used all the like ourselves also, we eat that food, and whatever waste is generated, we through this our Nisarguna technology, it is converted to methane. So this methane, when you burn, it will give CO2, and that again CO2 will go to the plant, will use that CO2. This is how the process is. That is called a natural balance is maintained. But what happens that when you are not following this method, suppose whatever waste is there, you are putting into the landfill or onto the road, what will happen? This whatever methane is there, directly it will go to the this one. Directly it will go to some atmosphere. So that is not a natural balance. So natural balance is that methane has to be burned and then it is converted to this one. So how the methane is generated, there are different pathways are there, but I will not go to details. But I'll just mention you that your waste is converted into methane. So different reactions are involved in that. So there are different bacteria also involved, like the aerobic bacteria I told you, anaerobic bacteria. So they are very, very microscopic bacteria. You cannot see by naked eye. You need a microscope to see these bacteria. So these are the some of the photographs of these bacteria actually. So names are also very, very this one actually, not very common, but you can just say that there is a bacteria or there is a microscopic world which we are not seeing, but they are there actually. Virus might be knowing now corona and all this thing. You cannot see it, but it is there. So similar way these bacteria are there. Like similar way bacteria are there present in a milk also. So that is called as lactobacillus. So these are bacteria actually. Okay. So then this is the gas actually. This is a blue flame. Whatever gas is coming out, that can be used for burning purpose. Okay. And then manure, I told you that manure, whatever is there, it is used for different applications. So we have analyzed what are the contents of this manure, and it is found that it is a very good content. When you apply this manure into the field, what happens? That increases the carbon content of the soil. Means that makes the soil more fertile. So the soil fertility is increased actually. So again, we have another technology for detection of this soil carbon. So that is I have mentioned here. But that soil carbon actually, that kit is used by many places by the farmers and all these things for analysis of their soil actually. Now again coming to the Nisarguna technology, I'll share you where some of the success stories of this technology. Okay, so we have seen that what is the technology, what is the problem is waste, what are the options available to treating the waste, and how we have developed the Nisarguna technology, and that technology has been implemented across the country. Now I will share you some of the success stories of this technology. So first example is a gas is used for community kitchen. There is a village, small place near Coimbatore actually. So what actually now these low income group people, they bring the waste through this cart, then it is being processed into the plant, and there is a community kitchen, like some 10-15 stores are there, 1 2 3 4 5 like these stores are there, and these people like morning and evening they start it, so that the people they come there, they cook their food and they go back actually. I mean not all, but some of the people they come, they cook or they boil the water, or some cooking of rice or something like that. So they are saving their part of the gas actually. So this is a very good example where this technology is used for community kitchen purpose actually. Okay, so this is one example. There is a Matheran, you might be knowing. Matheran is a small hill station near Mumbai, Karjat actually. So there is a no vehicle zone actually. So no vehicles are allowed there. So there are a lot of horses are there. So they were getting horse dung. So horse dung, we have plant has been constructed in 2008. So very, very long old plant. And whatever cow dung, horse dung is there, that is being processed into the plant, and that gas is used for street light purpose. And this plant has been very, very success story of this Nisarguna technology. That has got ISO certification also, and very, very well appreciated and very proved plant for different applications into the field. This is another plant just opposite to our BRC main gate. there is a Devnar, you might be knowing, that is a Asia's biggest slaughterhouse. That is called as a Devnar abattoir actually. So what happens actually, na, where when they cut that animal, na, there that intestine and all these things, they contain undigested grass and all these things. So it is a content like blood is there and all these things. So that grass and all this undigested food is there, na, they are putting into this plant actually. So this plant was built in 2017, like 4th year it is running successfully, and it is processing all whatever these undigested food, grass and all this thing material is there, and it is converted into gas, and that gas is used for this generator as well as gas turbine is being used for this purpose. So this is then some of the corporate places you might be knowing, like Thane, TCS is there, or even Wipro, Kochi. These are the places where this technology has been installed. See, you might be knowing, like earlier gobar gas plant, usually it is called as a backyard technology. Backyard technology means it was behind your house it is there, because nobody wants to see like that smell and all these things was there. But now with this Nisarguna technology and whatever modification we have done, it has come to the just near to the this plant is near to the reception actually, just near to the reception, or like corporate places it has been adopted. So that means if your process is good, people are accepting the technology. It is not like that you are so process needs to be very, very smooth. So what happens actually now, when we develop a technology, we transfer to the industries. Like industries are like many startups are coming, or many entrepreneurs are there. We transfer the know-how. That is means how to develop a plant. So that we give the training to them, and then they make a use of this technology, and then they set up at the different places. So like more than 300 plant installations all over the country. Then all types of waste, all types of biodegradable. I told you initially only that different type of biodegradable waste is processed in this plant, so it can be processed. So now like last 3-4 years, what we observed that there is a demand for a small capacity plants, like small housing society is there, or restaurants are there, so that cannot afford like bigger capacity plants, or they don't have a space. In Mumbai, you might be knowing, like there is a crunch of the space. So they requested us to develop a small capacity plant. So recently we have developed a plant made up of a PVC pipes actually. So that is useful for the housing societies, restaurants and all these things. So this is above ground plant, and that can process 10 kg, 20 kg, 25 kg, customized. Like any amount of waste is there, we can change the dimensions of that PVC pipes, and you get a different types of designs can be possible. So this is called as a helical design. Helical design means it starts from the base, that whatever waste is there, so you are adding from this mixer, then it's added pre-digester, and it goes down, and it comes up and up and up, and lastly it goes to the this manure collection tank, and then gas is generated. It is filled into the balloon. This is a balloon actually, and that balloon is connected to gas stove. So this is a very good technology for processing small amount of the waste. So all that cost involved in construction, then MS dome and all these things, it is saved in this plant. And very good for monitoring process parameters. This technology has been patented actually. Dr. Venugopalan sir is also involved in this work, and this work has been patented actually. We have transferred to different industries also, and they have taken up to the different establishments actually. So this is how the technology is spreading to different places. So again, some of the examples are there, like this is the plant I was mentioning about, the training school hostel backside. Now this is a lot of improvement is there into the design. Training school hostel, INS Kunjali. This is in Mumbai only. Hiranandani Thane, Mehetre I mentioned, TIFR. Then this is in Gujarat. Plant is there. Then different locations. all over country. This plant is functioning very well actually. So we are playing a major role in the Swachhata related activities, and Government of India, they have this Swachh Bharat Abhiyan when it was launched. From that time, we are playing a very important role in making this plant. See, this technology when it was transferred to the industries, so these many of the places wherever like Swachh Bharat Abhiyan is going on, most of the places these plants are there. So we are playing a major role in bringing down the waste to very useful products also, and cutting down the waste available into the cities. So this is how I want to show that how the research is can be converted into useful like technology, and technology having applications into the field actually. So this is how the small presentation is there. So we welcome you. Whatever you have any doubts, you can put into the chat box. So we'll try to address the doubts are there. Okay. So this is what the presentation is. Now we'll go to the any doubts are there, or we can share this one.
Sir, am I audible?
Yeah.
There are two doubts some students posted in the chat box.
Okay.
One Parvati V. Kumar, she has a doubt. The question is like this.
Uh-huh.
What are the gases that are produced while burning plastics?
Okay. Plastic. Okay. Plastic, when you burn, see, gases are like carbon dioxide. Basically, that is a polymer only. So that is a polymer only. So the CO2, carbon monoxide will be there, some dioxin and all these things. So that are, when you burn, that will be created. But that is an extra burden to the atmosphere. So that is not allowed. Yeah, I have stopped the screen. Yeah.
Then one more question. One Arnav Jayant,
Sir.
he posted a question. What contribution we as students make to waste management?
Very good. Very good. So as a student actually, or I can say like one can start from the home. So best way is that we have to segregate the waste. We can, along with your parents' help and all these things. So we have to segregate the waste at the source only. Means at the home only. Suppose waste is there. If you segregate it, that is become easy for us to process it further. Because what happens actually, when the mixed waste is coming to our plant, then it becomes difficult for us to process it. Because as I told you, this is a bacterial process, because bacteria, they degrade whatever biodegradable part is there. But if plastic is coming in that, so that inhibits the bacterial growth. So our aim is that we have the plants are there. Okay. So that can be processed at if you try to segregate waste at the home. So wet waste in a separate container, dry waste in a separate container. The person coming to take the waste, you have to give him separately. And from there, it will go to the field, to the biogas plant. Other way is that, so you can have a small basket in your home. We can give the basket actually. We have some baskets here at our training school hostel biogas plant. You can contact me for that. You can take that basket, and whatever waste is generated at your home, not liquid, not liquid, only dry way, like vegetable, unused vegetables and all these things. So you can make a very good compost actually. Whatever initial culture required for making that we will give. So you can make that a good quality compost actually. That is possible actually. So many students, they come actually in our biogas plant. They come for making the projects and all these things, preparation of the projects, everything they come actually. We guide the students and all this stuff. So as a student, so you can take a responsibility of whatever waste generated at your house is segregated. Other way is that whatever waste generated in our house, you can process at home only, home itself. Whatever help is required, we are ready to give. Initial culture and all these things, we will give you free of cost actually. So you can contact me. I'll give the mails and all these things to your school coordinators, so they can contact, and anytime any help is required, we'll give.
Sir, there is another question.
Sir.
That is, if methane is dangerous to ozone layer, why are we producing methane through this waste management?
Yes, actually, see, methane is dangerous to the ozone layer, but see, when you are throwing onto the land, you are fuel, making a use of a fuel, and that whatever after burning that fuel, you are connecting, you are getting CO2. That is a natural only. That is coming from the nature only. So extra CO2 is not generated in the process. But if you are throwing the waste, then there is a then there is a problem actually. See, nature, what happens? You can see, imagine a plant. So plant is taking the CO2, and then when plant dies, then that whatever is there, that is added into the soil. So that is a natural process. But when the plant is anaerobically decomposed, that methane will go to the atmosphere. That should not go. That is called as shortcutting. Natural way, if it is going, it will go to the soil. So that is that will go into the soil. That will not have an extra burden to the atmosphere. Now, why extra burden is there? Lot of vehicle pollution, or even a lot of industrial pollutions, they are creating the problems, and that's why the extra gases, they are creating problems to the ozone layer actually. Whatever methane is generated from this one, it is a natural, it is coming from the nature only. So there is we are not creating anything extra. Though methane is a dangerous, but we are using as a fuel, and that subsequent amount of fuel, because LPG you are saving, na? So that is also useful. See, if you want to generate LPG, you are again you need an industry, and all these things are there. So a lot of footprints are involved in that actually. When you are, and whatever waste, whatever methane we are generating, it is from the waste only. So it is coming from the natural source only. That's why it is not a burden.
Sir, one more question.
Sir.
Now, somebody inquired whether there are any small plants which can be adopted for individual houses or flats in the apartments.
Yeah, that is what I told. Na? That design where PVC pipe we have developed. Small apartment is there. 5 kg, 10 kg waste is there. Na? We can develop that technology. That is possible. And we have done it actually earlier in our this one. Small societies, it is possible. Small, like what 5 kg, 10 kg waste is there. We can develop actually. That is possible. You can contact me for any, suppose your society is ready to that. Na? We will give all the help required in setting up that plant.
Sir, is there any possibility to do organic farming without methane?
Without methane? No. See, organic farming is what? Organic farming with the organic inputs. Organic inputs are what? Manure, cow dung, manure, then compost, vermicompost, and all these things. So they are all organic inputs actually. So nowhere methane is involved. See, whatever manure is generated in biogas plant, that we are applying into the field. That is organic farming. Okay. Farming without chemical, that is organic farming. So methane is nowhere linked there actually. But whatever biogas plant is there, methane will be generated, and that methane you can use for burning. So that is useful for your organic farming only.
Okay.
So that question I did not understand what exactly they want to say, but organic farming is farming without chemical.
Okay. So
That,
here
uh-huh.
what you mean to say, the methane produced is natural.
Yeah. Correct.
Okay. For
Yeah, very good questions, sir. Their students are very this one, sir. Very good questions.
Mr. Ghosh,
Yes, sir. Yes, sir.
these are the questions which I could get from the chat box and I had put to our speaker. He answered. Now, next, what is to be?
Sir, I think you can propose the vote of thanks to the
Yeah.
speaker because
Okay.
session is formally now we can end the session.
So, So, Dr. Mehetre, thank you very much for sparing your time and coming to AES and for enlightening the students and some of our teachers and staff on the topic. And I think most of your answers to the questions raised by viewers are well answered. On behalf of Atomic Energy Education Society, I thank you very much. Thank you, sir. Thank you.